Started. So good evening, everyone. Thanks for joining us for our Chemical Engineering Ask Me Anything webinar. I will just dive right in here. So first, just to note, throughout the webinar, you are able to submit your questions using the Q&A function at the top of your screen. Questions will be answered throughout the webinar. We'll also hopefully at the end have some time for a moderated live Q&A. So I will hopefully be able to get your questions answered live for everyone. There is also a closed captioning function if that is something that will help you. So just click that little more button, the language and speech, and you can turn on live captions. I will note also if we don't get to your questions in this webinar, please feel free to email enginfo@uwaterloo.ca. We'll be more than happy to answer your questions there. So again, no chat feature, just the Q&A. So feel free to post your questions in there and we'll get through them during the webinar, hopefully at the end. First, I just want to give our territorial acknowledgement. So the University of Waterloo acknowledges that much of our work takes place on the traditional territory of the neutral Anishinaabe and Haudenosaunee peoples. Our main campus is situated on the Haldimand Tract, which is the land granted to the Six Nations that includes 6 miles on each side of the Grand River. Our active work towards reconciliation takes place across our campuses through research, learning, teaching, and community building, and is coordinated within the Office of Indigenous Relations. Visit nativeland.ca to learn more about the land that you occupy. So we have some experts on the call here. So myself, my name is Kelsey. My pronouns are she, her, and I'm the undergrad recruitment coordinator for the Faculty of Engineering. We're also joined, I will let them also introduce themselves when they speak, but Dr. Elizabeth Prince, who's an assistant professor at the Department of Chemical Engineering, Dr. Michael Vitelli, who is an assistant professor in the teaching stream for the Department of Chemical Engineering. We also have a current to-be chemical engineering student, Ayapan, and we are also joined by an alum, Emily, who graduated chemical engineering in 2023. So you will hear from all of these people today. They'll all share kind of their stories and chemical engineering as a whole, and also help you answer those questions throughout the webinar and towards the end. So I will first pass it off to Elizabeth and Michael.
Okay, great. So thank you for attending this webinar tonight. So my name is Elizabeth Prince. My pronouns are she, her, and I'm an assistant professor in the Department of Chemical Engineering. And so I do research on polymers and plastics at the University of Waterloo. So I'll start by introducing a bit about what chemical engineering is and what you'll learn in your degree. So what is chemical engineering? Chemical engineering is the engineering discipline that focuses on making stuff. And that stuff include everything from drugs, pharmaceuticals, to the food you eat, to any product you see around you. It's also the science of energy and many, many things. So it's a really diverse field of engineering. So what will I learn in my degree? So throughout your degree in chemical engineering, you'll learn everything from chemistry to math and physics and programming, all the tools that you need to do chemical engineering and do the engineering of making things. So I'll also introduce about our facilities, where you learn on the University of Waterloo campus, and then we'll talk a little bit about co-op and career opportunities. Next. And next slide. So what do I do with a degree in chemical engineering? So there's several examples of industries where chemical engineers can be found. That includes the automotive industry, designing engines, making the materials that you see in a car, from the plastics on your dashboard to your rubber tires. Chemical engineers are all over construction, and the construction of buildings, and the materials we need to build a building. And also a huge area where chemical engineering is very prominent is industrial production. So chemical engineers combine knowledge about materials, which includes polymers, paint, oils, energy storage, like emerging techniques like lithium-ion batteries. And we also know about how to produce these materials at a large scale in the chemical industry. Next slide. So what is chemical engineering? Essentially, chemical engineering is the engineering discipline that focuses on taking raw materials and turning them into valuable products in some way. And so we design the processes that are needed to produce these materials, transform some materials into new materials, and transport these materials and energy efficiently in a safe and sustainable way. So chemical engineers have a huge focus on sustainability nowadays, trying to find safe, economical, and environmentally friendly ways to operate the chemical processes that really drive our whole world and are used to make the food we eat and everything that you see in the world. And so a common question we get asked is what is the difference between chemistry and chemical engineering? And so chemistry is the science of how to make chemical reactions happen. And so what chemists do is they design chemical reactions to make new chemicals. They design new chemicals and they develop different reaction conditions to make those chemicals. But let's say you design a reaction to make, say, a drug. How do you go from making that drug in a lab on a small scale to making enough of that drug that millions of people can access its benefits? And so that's where chemical engineers come in. So in contrast with chemistry, chemical engineers also learn math and programming and physics and fluid mechanics, and they bring all of that knowledge together to allow us to produce materials and chemicals at a very large scale. So what do chemical engineers make? Pretty much anything you can think of, really. Think about eating a bag of chips. How did that bag of chips get made? Well, we know it's a potato that was fried in oil, but how do you make enough chips that you can sell them on a large scale to millions of people? That process involves chemical engineering, producing food at scale. Chemical engineers also design many of the advanced materials that we find in electronics and really any consumer products like the poker chips shown here, toys, any plastic, pretty much anything, a chemical engineer had to be involved in knowing how to produce that at a large scale. Next. And so why are chemical engineers known as the universal engineers? And so being that chemical engineering covers such a broad discipline, chemical engineers are often called universal engineers because they integrate knowledge from so many other engineering disciplines and so many sciences. And so we bring together knowledge from math, from chemistry, from programming, all across the board together to solve problems in the production of materials. And so, in addition to integrating all of that knowledge from different fields, we also, chemical engineers are found in pretty much every discipline, from looking at biomedical applications, like how do you produce drugs at scale? How do you design drugs to be more efficient? To producing food, to designing new energy systems for renewable energy. Every discipline really integrates chemical engineering. And so, given the universality of chemical engineering, that positions chemical engineering to be really involved in addressing sustainable development and trying to bring us towards a more sustainable world. And so, we often talk about this in terms of the United Nations Sustainable Development Goals. And so, chemical engineering is really critical in achieving these sustainable development goals, including zero hunger, knowing how to produce food at scale. Many chemical engineers design systems to produce clean and water filtration, but also achieving climate sustainability and addressing climate change and taking action towards climate change. Chemical engineering is really involved in developing carbon capture techniques and more efficient energy systems. And so across the board, chemical engineering is really central to addressing the UN Sustainable Development Goals. So now we'll talk a little bit about chemical engineering here at the University of Waterloo. And so chemical engineering has many unique advantages as a school to study. Waterloo has many advantages as a place to study chemical engineering. And so we have a large department that has many faculty members, many professors that do a wide range of research. They do advanced research on many, many different topics from biomedical chemical engineering to designing new energy systems to looking at polymers and addressing the plastic waste crisis like I do. But in combination with being a large department with a lot of resources, we also have very small class sizes. And so there's a lot of experiential investigations that students at Waterloo get to experience. There's many hands-on opportunities to work in the lab at Waterloo. There's also many, many research opportunities at Waterloo. And so it's a research-intensive university, and many students get the opportunity to work in the research labs on campus and get integrated with the innovative research that happens at Waterloo. It's also a very collaborative learning environment, and we have some world-renowned professors that are leaders in Canada and across the world in their field. Next slide. So we have many world-renowned professors in our Department of Chemical Engineering, including three of them highlighted here. So these are Canada Research Chairs, which means that they are recognized as leaders in Canada in their particular field of study. And so we have some of the leaders in Canada in researching regenerative medicine, stem cells, and tissue regeneration to try to treat many diseases. We also have Valerie Ward, who's a professor who does research on microalgae biomanufacturing, and Michael Fowler, who is a leader in the field of zero emissions vehicles and hydrogen energy systems. And so Professor Evelyn Yim is the University Research Chair on Regenerative Nanomedicine for treating things like heart disease. Okay, and so with that, I'll pass it off to my colleague, Professor Michael Vitelli.
Hi, everyone. Thank you again for joining us. So my job at the university is teaching. So I am in charge of teaching a whole bunch of courses. So if you come here, you'll definitely have me as one of your course instructors. In terms of academic requirements in engineering, what are you going to be learning if you choose chemical engineering? Well, all engineering needs a good basis in science and math. So this is very common across many different engineering types where you're looking at chemistry, physics, and calculus. What's special to chemical engineering is we also make you take biology as well. Now, you don't have to take biology in high school. We treat it as if you did not take biology in high school. So it'll be a review if you do take that course, but biology does play into that biochemical engineering side, which you will be able to learn with chemical engineering. We also look at process engineering. This is more of the application side of chemical engineering once you have the basis, where you're looking at how do reactions work? How do you calculate reaction rates? How do you do bioprocesses? How does that work? Thermodynamics, how does heat transfer, mass transfer work? So you're going to be looking at the process side. And then with all engineering types as well, we're moving to a more digital age where computers can do so much more than what they were able to do previously. So you're going to be studying how to code with numerical methods, how to do simulations of different design equipment, how to control processes. Say you want to run something at a particular temperature and pressure. How do you set up a controller to do that? And in terms of specializations that you could get in chemical engineering, so this is something that you would choose in your later years to really cater your education to where you want to work. We have things in environment and energy, where you're looking at things like air pollution, wastewater, energy in general. We have things like materials and manufacturing. This is more of what Ellie does in polymers and in food, things like that. And then if you want to take more of the modeling side, if you enjoy that, we also have a specialization in doing more simulations, whether that's in fluid dynamics or modeling what an entire chemical plant would do. This would be the specialization that you would complete. Okay, next slide. In terms of where you're going to be studying, we have two main buildings that you have classes and we have research labs in, as well as a whole bunch of other things. E6 is a very new classroom, or a new building. It has a couple study areas. It has most of the chemical engineering research labs as well. The Douglas Wright building is more of an older building. It's what we used to have. This is where we have our hands-on laboratories with all the equipment that you're going to be using in your labs, as well as our computer classrooms and some other offices. And then we also have specialized resources. Say that you want to do a project or you want to work on a design team that combines a whole bunch of engineering types together. This is where you'd be able to use things like the machine shop to build stuff or prototyping center. And again, there's always more computer labs with everything moving more digitally. So co-op is mandatory in all engineering in Waterloo. And this is a way for you to explore the different career types that you want to go to, earn some money, or gain experience. And this is paid co-op. In terms of the percentages, about 96% of our co-op grads are employed 6 months. So gaining that experience puts you ahead of the competition. There's a whole bunch of different jobs that you could get with your co-op jobs, from doing a lot of supply chain stuff, research, data analysis, and the list goes on and on and on. In terms of applying to different co-op jobs, we do have a portal, which makes it easy for you to find jobs that you would want to apply to work with co-op. In terms of how the co-op works, because at Waterloo, what happens is when you're on school term, you're here, and then right after you go on co-op, co-op starts right in your first year. In chemical engineering, we have 2 streams. Everyone starts together in fall. Half of you leave to go on your first co-op job. Half of you would continue on in your second term. And then you'd rotate back and forth between school and work term, minus a 8-month co-op that you get somewhere in your third year, where you get a larger experience, usually at a single company. After graduation, where could you go? So as Ellie explained in detail, there's a whole bunch of different careers you can get with chemical engineering. It is very, very broad, which means that chemical engineers will never go away. And then where you end up, you can cater towards your interests. If you like environmental work, you can look at things like air pollution or wastewater treatment. If you like materials and polymers, you could look at doing rubbers. You can look at plastics. If you like the bio side, that's where you get things like pharmaceuticals or like regenerative medicine. If you like cars have batteries, have materials that make cars. That's where chemical engineers would be used. If you like the energy spectrum, you can look at fuels and energy, whether that's solar, wind, or getting energy from biomass or biodiesel. You can look at just products in general, whether that be food or detergents, or basically any sort of product probably needs a chemical engineer. In terms of our graduates, where did they end up? Here is a pie chart showing you the different industries you could end up and the percentage of students that end there. Pharmaceuticals has a low percent, but most of our graduates end up in the process and manufacturing side. This makes sense because that's probably where the most jobs are for chemical engineering. It is in process and manufacturing. And if you think about that spectrum for process and manufacturing, that could be in a whole bunch of different industries. So it really takes up a larger portion. All right. Now I am going to turn it over to our student, Ayapan. I had the pleasure of teaching him last term, and he's going to tell you a little bit about his co-op experience.
My name is Ayapan and just finished my 2B term last term, currently on my 3rd co-op. I've done 3 co-ops so far. First one was a materials engineering student at GFL that mainly dealt with construction materials asphalt, cement, and concrete, and running chemical analysis. I think that's what my last co-op that had a huge focus on chemical engineering. And then my second co-op, I did it at the MTO as an asset management engineer. And that was mainly doing data visualizations and working on one large consulting project for the ministry. And then my current co-op right now, I'm doing risk consulting at PwC. And what I love about chemical engineering is it's allowed me to access these different industries that I initially wouldn't have thought that I would have been able to enter. As I'm working with a lot of people who are in accounting backgrounds or business backgrounds, but having that experience in chemical engineering of assessing a process from end to end is highly beneficial, as that's what we're doing as well. So it's all about the transferable skills that you learn in the program and the soft skills that are applicable in various industries. And that's just the benefit of having a rigorous degree that you end up working on your soft skills as well through the availabilities in like Waterloo with interview prep and all the center of educational stuff that they have. So that's a great opportunity. And now I'd like to pass it on to Emily, who's a chemical engineering graduate student and a master's student.
Okay, give me a second. So hello everyone. So my name is Emily Smythe and I graduated from chemical engineering at the University of Waterloo in 2023. So currently I'm doing my master's here where I'm focusing on the process of converting ammonia to hydrogen for hydrogen refueling stations. But I also work part-time as a graduate process engineering engineer at SysCAD, which does plant simulation. And I worked with them before I started my master's and decided to work with them part-time throughout my master's. And I've been to like a lot of conferences and was able to present some of my work there. So now just to go through my co-op experiences. So I've had an opportunity to explore various engineering disciplines. So allow me to discover what I really enjoyed and then what co-ops what wasn't quite for me. So while my current job is different from many of my co-op positions, these experiences were invaluable in helping me identify my interests and build a strong foundation of soft skills, many of which I rely on my work and studies today. So some of my co-op experiences in my undergrad include being an engineering assistant at Verismine Technologies, being also a lab assistant at XPS Expert Process Solutions, supply chain intern at Pepsi, so the Quaker plant. Oh, sorry. Also professional development teaching assistant at the University of Waterloo, and then also an engineering analyst at Toyota Manufacturing Canada. So all these have been in different industries in mining, food processing, academia, and then also car manufacturing. So I had a little bit of everything. And then something else I wanted to mention throughout co-ops is that I was able to learn a lot from my coworkers and meet other co-op students from other departments and faculties. So it was co-op was also very nice in order to pay my tuition every term. And then one advice I would like to give incoming students, especially if you're applying for co-op for your first time, is to never give up and to also keep an open mind when you're applying to different jobs. Usually the first co-op is always the hardest to get. For example, I didn't find mine until December of my 1A term since I was stream 4. But there are many resources on campus to help people, especially when you're looking for your first co-op. And there are many things such as resume critiques for upper years. Go on to the next slide. So for what I love about chemical engineering is that it opens up opportunity across so many industries, offering a diverse career path. So I'm drawn to the way that chemical engineering can make a meaningful impact, whether it's through environmental advancements, creating safer products, or optimizing processes to improve efficiency. I particularly enjoy using process simulation to enhance operations. So, and then studying chemical engineering was incredibly rewarding, and the friendships and professional connections I built along the way have been also very valuable as technical knowledge, making this field truly special for me. Some other points I also wanted to make that I've also had many great professors who taught me during my undergrad who were also willing to help any of the students if you were struggling or had any questions. The chemical engineering at Waterloo also had a lot of hands-on labs, so you can apply your knowledge, and that was like almost every term. And then the final thing that I loved about the program was my class. So we got along really well. We helped each other, and I still see a few of them every so often. So I've also included some things about like my capstone when I got my eye ring and just hanging out with different people. So yeah, there's a lot to like about chemical engineering here.
Awesome, thank you. All right, we're just gonna jump back real quick. 1 sec. Michael is just going to go over a couple more slides.
So this particular student, Nick, still is at the University of Waterloo. He's completing his PhD in chemical engineering now. And really, he'd like to share some of his experience. He knew chemical engineering was right for him. He really liked the mixture of chemistry meeting physics and math. And what he really enjoyed was the co-op part, because he was able to dip his feet into many different industries, just like Ayapan, just like Emily. Where he ended up working was in pharmaceuticals, wastewater, and HVAC. And then because he was able to work in a whole bunch of different industries, it really allows you to get a broader understanding of what you could potentially do in chemical engineering, where you see how courses that you do in first and second year, especially these building courses, can be applied to a whole bunch of different industries where the science is mainly the same, but you're doing something completely different. Okay, so in chemical engineering, every day is an adventure. That's the motto that this particular student likes to live life by. Every single course that you take will be different, but they will build on one another. So it's going to feel like you're learning new stuff and building your knowledge day by day. The people that you work with, the friends that you make will help you along the way. You being in a cohort system where you have all your classes with the same people allows you to become very, very close to your classmates. And then with interacting and combining all the technical aspects, it really helps you grow that knowledge in chemical engineering.
Awesome, thank you. All right. So before we see if anyone else has any questions, I just wanted to kind of give a little recap here of some ways to reach out to us. So you can always come and visit us for a tour. This term, we do tours Monday, Wednesday, and Friday. So you can go to our website and sign up for a tour. You can join us at any of our upcoming events. We just had our recent fall open house. Hopefully some of you were there. We will have our March open house coming up in the new year. If you do have any admission questions or anything after the webinar, you can feel free to reach out to enginfo@uwaterloo.ca. We'll be more than happy to answer your questions. I did also want to mention a great way to chat with current students is our Ask a Warrior platform. So you can log on to our platform and you can reach out to any student and any student ambassador, that we have in certain programs, and you can reach out to them and ask them any questions you have, or set up a video call, which is a great way to kind of hear from current students and ask them any questions and get that student experience side of things outside of this webinar. So it is only 8:30. Anyone has any questions, please feel free to put them in the chat. Now there's too many of us on tonight, but please feel free if you have any questions. I'm going to post them in the Q&A. If my speakers want to turn their cameras on, we can see if there are any questions in here. Michael or Elizabeth, did you want to touch on the specializations? Someone had a question about if you focus in chemical engineering. So I think they're kind of talking more about those specializations that you mentioned. If you could just expand on those.
So I'm just reading it now.
Okay.
So chemical engineering at Waterloo, you have your core courses. That's your chemistry, physics, math, and a lot of the application-based classes like your separations, your reactions, your heat and mass transfer. Those are all mandatory courses that all chemical engineers take. However, in your final year, you get something called technical electives. And those technical electives are in a whole bunch of different industries. Some of them having to do with environment, some of it having to do with process simulation, some of it having to do with food, bio, etc. So those courses there are what you can cater towards what you enjoy. I believe you get 4 technical electives in your 4th year. So it's 4 courses that you get to choose in chemical engineering.
So I can come, I teach one of, or next semester I will be teaching one of the technical electives. So I'll be teaching a course on biomaterials and biomedical design. So there are courses available if you're interested in more the biomedical side of chemical engineering.
In terms of the specializations, you don't actually even start them until you start choosing your technical electives. So you don't need to worry about specializations until you are in 3rd and 4th year where you're choosing your technical electives. So that allows you to kind of decide what you want to do through your co-ops, through the courses that you enjoy, and then from there you can choose. In terms of programming, there is a programming course in 1st year, 1st term. We assume that you have not taken any programming, so we start from the very basics. You do not need to start off with any programming skills. That is what you're going to be developing here.
I
So
can
for
answer the
co-op,
question. Oh,
sorry.
sorry. I can answer the question about co-op. So people like have their co-ops like in so many places. I had friends who went to China, the US, California, or like anywhere. So, but for living though, you have to like find it yourself. So typically the employers will not like provide you with anything. Like it's like if you were going to like a job or like moving to like a new city, even here to Waterloo, after 1st year, if you're not staying in residence, then you have to go look for your own living. Usually if you're going to places with a lot of other co-op students, you can find apartments or like even houses that you can go live with them. I know for one of my co-op placements, I didn't think Peterborough was in the middle of nowhere, but I got a little bit of money from Quaker because apparently they said it was kind of in the middle of nowhere. So I got some money to help with some of my living expenses. So yeah, maybe if you're living in the middle of nowhere, some companies will help. But typically, yeah, you have to go find for your own apartment or somewhere to live if you are doing a co-op, not at home.
Some companies also provide connections. So I had a job offer or co-op offer for this term in BC, and it was for a mining company, and they would house all their co-op students in one of the locations near the mines. So then you're building a community in a sense. So you have to know the group of interns there as well. And there will be the senior managers and managers living close to the site as well. And they did provide like a stipend in a sense to help alleviate the cost of housing.
And it's important to remember the co-ops that you do at Waterloo are paid, and so you can pay your living expenses from the salary you're making at your co-op.
Someone asked, how would you use programming for chemical engineering?
So programming with chemical engineering is solving your math, basically solving more advanced calculus problems. That is where a lot of the programming comes from, or combining a whole bunch of things into a simulation. So in terms of the calculus that you're solving, eventually you get to a point where you can't do the math by hand. And that's where we start using computer systems in order to actually solve these problems. It's not something that you see a lot in your first couple years, but eventually a lot of your core courses will have programming in them in third year and beyond. In terms of simulation, Emily does simulation, so maybe she could speak.
Oh yeah, so for my part-time job, I do simulations, and at least for chemical engineering, it makes it like definitely like easier using like simulations like for the processes. I think even now like there's some research that focus in using like machine learning and software simulation, especially for those models that you cannot predict using like equations. So for example, I know for sugar manufacturing for crystallization, they're looking into that. But yeah, programming, it does become a little bit more heavier in upper years. I know when I graduated, we just used MATLAB, but thankfully I know that the classes after me who graduated, they use Python. So I do think Python's a little bit more valuable, just because they use it in like so many industries, and it's very easy to learn. Like I entered chemical engineering not knowing a single thing of programming. So and they'll teach everything from scratch, and like you'll learn how to like use those in the future.
There's a question about, are there any cool startups related to chemical engineering at Waterloo? There are many startups that have come out of our department. One example is a company, Tyromer, which looks at recycling the rubber in car tires. And so they actually have a pilot plant that's recycling car tires right now, because with current methods, car tires aren't actually recyclable. But this company, Tyromer, that is a spin out from Waterloo, is actually recycling the rubber in car tires. There's also a startup related to chemical engineering at Waterloo that I know of that is looking at recycling dairy product waste to make plastics, to make bioplastics and biodegradable plastics from the waste from producing dairy products. But that's just to name a few. There are actually many, many that you can find. And there's the Velocity Incubator close to campus in Kitchener. And that's a startup incubator located nearby that has many startups at Waterloo.
Here. Someone saying Chem Eng is the toughest program on campus. Is it possible to graduate in 5 years? So all of our programs are co-op programs, so they are 5-year programs.
I just want to add something to that. Like I know there's a lot of tough programs, and sometimes they'll say like some engineering programs will say they're better than others, but it is possible to graduate within 5 years even with co-op. But I do know like a lot of students, or like even some of my friends, that did take an extra year, and that is totally fine. Whether sometimes they just extended their co-op or they either failed a term and they just need to take it again. So you don't need, if it happens that you don't graduate in 5 years, that is totally fine.
We do have an open house. Our March open house is on Saturday, March 22nd. Someone was asking more about the specializations. Is it possible to specialize in genetic engineering in your 4th year?
We don't have a genetic engineering. There is some technical elective courses that would help you gain some of that knowledge. I know that we have a tissue engineering course as a technical elective that Evelyn teaches. That'd be one. We have a bioprocess engineering course, an advanced bioprocess engineering course that helps you gain some of that insight. It's not as much genetic as it is using cells to produce certain products, but those are the types of things that we have, not genetics by itself, no.
Yeah, we don't specifically have genetics, but there are a lot of courses that incorporate genetics, like the biomaterials and biomedical design course. We also have a course that focuses on nanomedicine and all of that, and a biochemical engineering course, and all of that integrates genetics. So you do get to learn some about that, some stuff about that if that's what you're interested in.
They're struggling to determine if chemical engineering is the right path. They enjoy chemistry, less confident about the design component. How much emphasis is placed on design in this field, and what are some types of design work involved?
So in terms of your courses that you take, a lot of the design courses are in third and fourth year. The reason why this is because you don't have the knowledge to design very much when you first come in. So design isn't a big aspect until you build that foundation. When you talk about design, it's not you're designing something from new, it's that you're taking something that's done and you're trying to scale it up to make it profitable or make it able to be done on a large scale. Your courses that have more design are mostly third, fourth year, where in fourth year you have an entire course that teaches you how to simulate, say, a production plant. And then you have some projects more in fourth year as well that have to do more with you designing something or coming up or reading or doing some research about something.
So one of the unique opportunities that you get in fourth year, and this is across Waterloo, is capstone design projects, which is really student-directed design project in your final year at Waterloo, and you get to pick the project as a team with a team of other students, and you're supervised by a professor, and you get to design any product. And there's a huge range of projects that students take on in that place, including, say, new processes for recycling plastics, I'm working with a group right now that's looking at producing a hydrogel patch for monitoring radiation during radiation therapy for treating cancer. So it's a opportunity to sort of explore another area of engineering.
Answer. Yes, options and specializations. You can do both. Oh, Emily, you responded to that. Do you want to speak about your response of doing an option and specialization?
Oh yeah, I've done both. So it's not technically like, I know some programs or other like faculties or other universities will allow you to do a minor, but because of the heavy course load that we have as engineerings, you can't have a minor, but you can do something called an option. So there's different types of options, and at least for chemical engineering, the easiest one to take is management science, because some of the courses like overlap, so you can have a course like that counts twice towards something. So yeah, there's something like management science, you can do an option like an AI, but you do have to overload, so you have to take more courses than your usual like semester, or you can take courses during your co-op. And then for your specialization, yeah, you can, that is just in fourth year, and you do choose specific courses for what you want, and there is 3 of them that I know of for now.
Are there any courses related to nuclear/mining engineering?
We don't have any technical electives so fourth year classes that are directly nuclear mining. However, if you think about the courses that you're taking through your time, you're going to gain the skills to do nuclear and mining. Nuclear would relate to things like heat and mass transfer and reaction engineering. So you do get the basis in order to do stuff like nuclear. Mining, it would be more separation, I believe. So again, you're doing courses in separation, you might have a couple of examples relating to mining. However, we don't have courses that are just nuclear or just mining.
I think we've answered all the questions. Please feel free to type any more questions you guys have. I don't know if you guys all really touched on it. If everyone on camera wants to like talk about why they chose chemical engineering. To see. I don't know who wants to start.
I chose chemical engineering because I was interested in math, science, and physics. And that was like the perfect major in a sense. But then as I started like going through co-ops, I liked more uh, like a collaborative work environment. So I wasn't as interested in working in like a lab or remote location. So I started deviating to the consulting path. But that is something that a lot of chemical engineers and mechanical engineers do end up doing. So it is still quite related.
I can go next. So I'm a assistant professor at Waterloo. I actually did my undergraduate degree in chemistry, not chemical engineering, and I found my way into chemical engineering over time. So I picked it because I love chemistry and I think it's the coolest thing in the world and it's really fascinating. And then when I went to do a PhD, I became really interested in materials. Including biomaterials and things like gels and plastics and all of their interesting healthcare applications and sustainability challenges. And through that, I found my way to working with more engineers because I find the most interesting problems are the ones that are really interdisciplinary and look at things in that way. And that's really what chemical engineering does. It integrates knowledge from different disciplines. Um, and so that's why I really like chemical engineering.
Oh, I can go next. So it's kind of like a process of elimination for me. So I kind of saw like the list of engineering programs that they offered here. And also I did enjoy like chemistry in high school, which isn't really the chemistry that you do in chemical engineering, but it still like helped a bit. Um, but yeah, it just sounded like the most appealing when I was like looking through like all the engineering degrees. And I am more like I do like more like the manufacturing side. So that's also kind of like what appealed me for to chemical engineering.
Thanks.
For me, it was in grade 12 when I was doing chemistry. I knew I always wanted engineering because I really like where math and physics meet, but I couldn't choose the type until it was my grade 12 chemistry teacher who happened to be a chemical engineer. And she should suggested it to me. And then as I was going through chemical engineering, I never took biology in high school, but I really, really enjoyed when biology met calculus. So for me, I started going down the path of pharmaceuticals, and I ended up doing my PhD in chemical engineering, but in vaccine manufacturing, modeling bioreactors for vaccine manufacturing.
Great. Thank you. All right, there's no more questions. Does anyone have any of you have anything else to say or end this note on the webinar? Anything to share? All right. Well,
I can just say
go
one
ahead.
thing. Sorry.
Yeah, no.
I know I used to give like tours before here at Waterloo for like the undergrads, just for general engineering. And then one thing I would say like kind of like why I chose to actually come to Waterloo compared to like any other universities, because I do live like 5 hours away from here. So it was like I did have to move like away from home. And I chose it because of course first the co-op. We're well known for like our co-op. And then I also chose it because of the smaller classrooms. So from 1A, from the beginning, you do start just with your cohort. 1A, it's like stream 4 and stream 8, so you are about 160. But after that, your classrooms are maybe like 60 to 80 people, which is smaller compared to other universities. So I did enjoy that. And you're also always with the same people throughout like every year, which made it easier to make connections with people in your program and like get to know each other. So we kind of like we're like a family towards the end. So that's kind of like also like why I chose to come here. And that's what's different compared to other universities.
I just want to add like the faculty of the university, specifically the chemical engineering department, is great as they have amazing instructors and it's more of a built community. As I remember last term, we had a water balloon fight during after midterms, which was quite interesting and fun. And then all the professors are great as well with office hours, and you have multiple resources to get on track and get help during like final season, which I find quite helpful in managing stress and exams. But then it's also a great outlook towards co-ops and research opportunities, as there are many professors that are looking to get students in their labs as well.
Thank you. All right. Well, I think I will wrap up. Thank you, everyone, Michael, Elizabeth, and Emily, and everyone for joining us tonight. The webinar it is being recorded, so it will be emailed out to everyone hopefully in the next 2 weeks or so. Again, I would recommend coming to visit campus for a tour or our March open house, or you can reach out to a current student on our Ask a Warrior platform. But other than that, if you have any other questions, you can email info@uwaterloo.ca, and we'll be more than happy to answer any of your questions. But with that, hope everyone has a great night, and thank you again.